Hi and welcome to the Mathemagic channel. Today we look at how we can integrate the integral of pi divided by the square root of 8 minus 2x squared dx with a trig substitution. Let's try it out. So this question is it's a pretty nice question because it encompasses a technique that is a technique that needs to be known, and so we're going to cover it today. So the first thing to do is always to take the numbers outside if we can, to make integration a little bit easier. So what we can do is we can take a pi outside of the integral and say that this is the integral of 1 over, and at the bottom we could factorize the denominator by 2. So we could say that this is 2 times 4 minus x squared dx. And this leads us to being able to take root 2 out. So we can say that this is equal to pi divided by the square root of 2 times the integral of 1 over the square root of 4 minus x squared dx. So it's not very easy here to find an integral for 1 over the square root of 4 minus x squared because we don't have any x's at the top, so it's not going to integrate nicely with natural logarithms, for example. And it's a good idea to look at trig substitutions here. More specifically, when you have a squared minus x squared, you should always look to do a substitution with x equal a sine theta. And so this is something which I would encourage you to do anytime you see a question of this kind. The reason why it's interesting to do x equal a sine theta is that we will be able to change it into cos theta using the Pythagorean identity. So let's go ahead and do that. So in our example here, let's say that the a value is 2. So we could change 4 minus x squared into, so the 4 stays the same, so we could say that this is 2 squared minus, so a is 2, right? So we're going to say 2 squared sine theta. And the reason why this is good here is because we can equate this to 4 factor of 1 minus sine squared theta. And I think you can see where this is going. This is going to be 4 factor of cos squared theta. And since this is stuck under a square root, it'll be very useful and we'll be able to take it out. So using the work that we've done here, we can say that this is equal to pi divided by root 2 times the integral of 1 over, and so we're changing the 4 minus x squared, we're going to change that into the square root of 4 cos squared theta, and we're going to have to change the dx as well here. So let's do that on the side. So whenever you do a substitution, it's important to change theta in terms of x and vice versa. So we know that x is equal to a sine theta, and therefore dx by d theta is going to be equal to a cos theta. In case the a value here we had was 2, so we can say that this is 2 cosine theta. So we can simplify our dx as 2 cosine theta d theta and replace that value back into our equation. So we're going to change the dx. And so our dx value here becomes 2 cosine theta d theta. And so for our next line, we're going to have pi over root 2 times the integral of, so at the top we'll have 2 cosine theta d theta, and at the bottom we do the square root of 4, which is 2, and the square root of cos squared, which is cos. So we're going to be left with 2 cosine theta. And you can see here that 2 cosine theta over 2 cosine theta is going to simplify so nicely. In fact, they're just going to cancel each other out and leave you with a 1, which is really nice. So the integral will become the integral from, so it's still an indefinite integral of pi over root 2 times the integral of 1 d theta, or simply d theta. And to integrate this, all you need to do is to add theta. So you can say that this is pi divided by root 2 times theta, and plus a constant. Now to finish this question, we need to put everything back in terms of x. So we know that x is equal to a sine theta, but we need to find an expression for theta in terms of x. So we can isolate theta. So x over a is equal to the sine of theta. And so to isolate theta here, we should probably arcsine both sides. So if we do that on the left-hand side, we're going to get arcsine of x over a. And on the right-hand side, arcsine of sine theta is going to cancel out, which is just going to leave us with theta. So now that we have a value for theta, we can put that back into our equation. And so our final answer here is going to be pi over the square root of 2 times arcsine of x over 2 and plus a constant. Now this is the final answer for this question. It's in simplest form, and because it's indefinite, we have to add a constant to it. I hope you enjoyed this question. So whenever you see a squared minus x squared in the denominator and you're thinking about a substitution, make sure to use a sine theta, as it changes so nicely into cosine theta. Try and practice a few questions which look a little bit like this until you make sure that you have the technique down. Thank you so much for watching. We hope you enjoyed this video. Please remember to like and subscribe to the Mathemagic channel, and we shall see you on the next one. Bye bye!